Alright, so let's start a new chapter. Today we're going to be talking about square roots and the square principle. So let's get started. Most of you probably have seen the following symbol. And you've probably memorized that when you see that you're supposed to spit out 2. And in your head you may have forgotten why. And so we're here to answer why. This is the square root symbol. The reason it's called the square root is because it's asking, what do you square to get 4? And the reason why we use the word square is because in a perfect square, if the sides are size x, right, and that's because it's a square, the two sides are congruent, then the area is just x squared, right? And so we call it squaring when we multiply a number by itself because of that little box down there. And so the square root symbol asks, what positive number squared is x? Right, so if I write the square root of 9, the answer is 3 because 3 squared is 9. And if I write the square root of 25, I get 5. Why? Because 5 squared is 25. And this is important. What positive number? When you see just a square root symbol, it always wants the positive number. And let's talk about why it's possible that there could be other answers. If you look at -2 squared, it's -2 times -2. Right? And you should remember something about 2 negatives always cancel. Right? And so you're left with 2 times 2, which is 4. And so if you look at the square root of 4, you might think to yourself, well, the answer is anything that when you square it you get 4. But remember, it has to be just positive 2 because the square root symbol always wants only the positive square root, not the negative square root. Let's go ahead and look at what happens when we have more than one letter. So suppose we have the square root of x squared. We're going to write x because, now look at this, because x squared is what's under, right? This is x squared under there. This is x squared, which is what we wrote there. See? Because 3 is that, and 9 is what's under there. 5 is that, 25 is what's under there. So the square root of x squared is x because x squared is the same thing as x squared. How about the square root of y to the 4th? Well, that's going to be y squared because, now here's where we have to be good, y squared squared, right, that's that, is y to the 4th. And let's convince ourselves y squared squared is y squared times y squared, which is y times y times y times y, right? Y squared is y times y. And since there's 4 y's, we get y to the 4th. let's do something a little more complicated. The square root of x squared y squared, that's going to be xy, because, well, it should be because xy squared is x squared y squared. And let's check that out. Xy times xy. Remember, the order you multiply in, if you have, see, 4 things here being multiplied, right? You can multiply them in any order, so you get x times y, which is definitely x squared times y squared. And so when you squared xy, you got what was underneath the radical. So that's the really important thing about square roots. If you have 2 things going on, see how we had x squared and y squared. Suppose we had 9x to the 6th. Well, you can deal with the 9 and the x to the 6th separately. The square root of 9 is 3, and x to the 6th is x cubed. Again, because 3x cubed squared is 9x to the 6th, and we'll check it. We have 3x squared cubed times 3x cubed. Remember, we can do 3 times 3 times x cubed, which is 9x to the 6th, because there's 3 followed by 3 x's, and so we have 6 total x's when we multiply them. And so that worked out just fine. The square principle is kind of like square roots, except in reverse. What it says is that if a squared equals b, then a equals plus or minus the square root of b. So remember we said before, when you see the square root symbol here, it only gives you one answer. But we saw that there were 2 answers that got you to a number, right? If we take 2 and square it, we get 4. And if we take negative 2 and square it, we get 4. And so I ask you, if x squared equals 4, you're going to tell me that x equals 2 and x equals negative 2 are answers. And if you look back at the square principle, what it says is that if you have something like x squared equals 4, then x has to equal plus or minus the square root of 4, which is plus or minus 2. The same thing we had said from our inspection. Okay, so we have this idea that whenever we have something squared, we get plus or minus the square root. Let's look at another example and then see what sort of more complicated things we can do with this. Suppose I told you x squared equals 16. We know x equals plus or minus the square root of 16. And that means x equals plus or minus 4. And let's apply that to something more complicated. Suppose I told you x minus 1 squared was 16. Now, look, instead of an x, we now have an x minus 1. But that shouldn't matter. The square principle says whenever you have something squared equaling b, then that something, whatever it is, has to equal plus or minus b. This box is what we're squaring. So that box, otherwise known as x minus 1, is going to equal plus or minus radical 16. So you can see here how we replaced x with x minus 1, and that's going to continue throughout the problem. So we get x minus 1 equals plus or minus 4, and if we if we write this as two answers, we get x minus 1 equals 4 and x minus 1 equals negative 4. Adding 1 to both sides of both of these equations, we get x equals 5 and x equals negative 3. So you can see how we can actually get more interesting answers by having more interesting things squared. And that brings up a good point. Suppose I asked you to take the square root of x minus 3 squared. Well, remember, whenever you had perfect squares like x squared, we got x. Here we have x minus 3 squared, so we're going to get x minus 3. We can do our y again. Y. The reason is x minus 3 squared, that's that, equals x minus 3 squared, that's that. So that's basically it. We can write up something important, things that don't make sense. Squares are not negative. Let me put a lot of underlines here. Let's even add a couple in color. Remember, negative 2 squared was 4, and 2 squared was 4. So if you start with a negative number and you square it, you get a positive number. If you start with a positive number and square it, you get a positive number. You don't get a negative number. So another thing that doesn't make sense, because squares are not negative, square roots don't like negatives. So the square root of negative 4 is, I guess, terrible. It's not okay. Now, that's important for you to remember that only the thing inside the square root can't be negative. Negative square root of 4 is just negative 2 because the square root of 4 is 2, and all you did was you carried the negative sign with it. So it's okay if it's positive inside. It's not okay if it's negative inside. So other things, again, negative radical negative 9. This is bad. Right? The reason it's bad is that the inside is negative. And it's really important to remember that the only thing that the square root is going to freak out about is if the inside is negative. Also bad, the square principle doesn't apply to things like that, right? Remember, the square principle says that this means that x should equal plus or minus radical negative 4. And we just said that that's terrible, not okay. Since this is not okay, this is not okay. So that's really all I want to talk about in this first video. That when you're taking square roots, you're just looking for the thing that when you square it, you get what's underneath. And that the square principle says that if you have a square equaling something, that you need both the positive and the negative square roots as your answer. So go ahead, do the homework. I will see you in class.